All right, so now in the last note, what you did look at was polynomial functions, but they were in what's called standard form. All right, now what we're going to look at right now is polynomial functions in factored form. And so a polynomial written in the form y equals a, and then you have x minus alpha times x minus beta times x minus gamma, and I could go on because there's a bunch of Greek letters, is said to be in factored form, where a is the leading coefficient and the gamma or the alpha, the beta, the gamma, and I believe that's phi are x-intercepts. All right, now the key here is the degree of your polynomial is determined by the number of x's you have. All right, so that's something to remember here. Now, I get to my first one here. So I have 1, 2, 3 x's. So I know the degree of this polynomial. Let's write this in here. Degree of polynomial is 3. All right, now, more importantly, and we'll get to other things, is that when I look for the x-intercepts are determined by which number makes these terms in brackets equal to 0. And so for my first brackets, I'm going to write down my x-intercepts here. X minus 4, the number that I can substitute in for x that makes that bracket equal to 0 is 4. The next one, I have x minus 1. Well, if I plug a 1 in for x, I get 0. And then the last one is what value for x could make x plus 3 equal to 0? Well, negative 3. All right, so there we go. We got that right off the bat. So there's our x-intercepts. Now we can also, because we're trying to sketch a graph here, so I'm trying to get as much information as I can. That makes it easy. All right. Now, the y-intercepts. Y-intercepts is I make x is equal to 0 and you have a y-intercept, okay? And so if I plug x equals 0 into my equation, which is, not f of x because I'm typing in f of 0 here, I get, we'll see that negative sign in front of the brackets. It's really a negative 1, if you will. Then again, I'm substituting 0 in for x, so I have 0 minus 4 times 0 minus 1, and then times 0 plus 3. Try to extend that out. All right, so if I can figure that out, which I'm sure I can here, I have f of 0 is equal to, let's see, I got negative 1. Then I've got a minus 4. Then times a minus 1. And then times a 3. And let's see, negative 1 times negative 4 is positive 4. But then I times it by negative 1, I get negative 4 again. And then times 3. And it looks like my y-intercept is negative 12. So I haven't even finished yet, but so far what I have is the fact that, well, okay, we'll get to, I'm going to plot some points. Why not? So my x-intercepts, that's my values on my x-axis. So the first one here is 4. There's 1 point on my graph. I have another x-intercept of 1. All right, and the other one is negative 3. And then, I'll get to my y-intercept because it's negative 12. I don't know if I'm going to have to adjust this graph. We'll get to that. Usually, maybe I skipped ahead a bit and started graphing early. Usually, my last thing I do is graph. Now, so we'll get back to normal. Now, the leading coefficient, I can calculate that. The leading coefficient of our function is always equal to because I want to know my end behaviors, right? I already know this is an odd degree because the degree of the polynomial is 3, but I need to know if my leading coefficient is positive or negative because that will help me with my end behaviors. All right, now my leading coefficient here, I have a negative sign out front, so I have to account for that. That's -1. Now the other parts where you get your leading coefficient is the number in front of the x. Well, you look at our x, in front of the first x, there's nothing, but there really is. There's a secret 1. I look in front of my second x, there's a 1. I look in front of my third x, there's a 1. So my leading coefficient here is -1 times 1 times 1 times 1, -1. Now the reason I need to really know that is that my end behaviors then is that I know this degree of polynomial is odd and the leading coefficient is negative. So I think back to what I was going in before with my x cubed, where my negative x cubed looks like this. So in the end, my end behaviors as x approaches -infinity, because again, end behaviors is like you're standing in the middle of the graph and you're looking to the left. And in this case, my y is going to approach infinity. All right, so that actually helps me with my graph, is that I know that on my far left point here, my far left intercept, this graph's going to shoot up this way. Now on my other end behavior, as I'm looking far to the right, so x approaches infinity, and I go over here again just for reference, my negative x cubed graph, it's going to -infinity. And so I go to my far right point, because that's as x approaches infinity, and this thing is going to head downwards. Now here's what we really are looking at now is what's in the middle. So what I'm going to do is I'm going to find values in between my x-intercepts. All right. And so because I want to know what's going on here between these two blue points, the x equals -3 and x equals 1, but I also want to know what's going on or how it looks between x equals 1 and x equals 4. So I'm going to pick a point in between these two. I don't know. I'm going to go with x equals -2. So I'm going to find what the y value is at x equals -2. Now I got to go up to my graph here. So that means I'm going to plug in a -2 into each of these x's and find out what my actual y value would be. So I have a -1 leading coefficient. Then it's x minus 4. So again, I'm putting in a -2 minus 4. And this, so it looks normal. All right, and then let's see, the next part is x minus 1, so I'm going to have a -2 minus 1. So just plugging into the equation, and then I have x plus 3, so I'm going to have a -2 plus 3. All right, so where does that get me in terms of just my y value? I'm going to have a -1 times a -6, okay, times a -3. Then just times a 1. All right, well, -1 times -6 is 6. Times -3 is -18. Times 1 is -18. So there's one value I know in between two of my x-intercepts. Now I'm also going to pick a value that's in between my other two x-intercepts. So I don't know, I'm going to try F3. So I'm going to go F of 3. I could have picked, what's the easiest ones here? I could have picked 2 or 3. X equals 2 or 3. So I'm going to pick X equals F of 3. All right. So now again, plugging in the equation, I got a leading coefficient there of -1, or a leading number there of -1. Let's see here. It is the leading coefficient as well. So in the first part, it's X minus 4. So I'm going to have a 3 minus 4. All right. And then the next part is X minus 1. I'm going to have a 3 minus 1. And then the last part is x plus 3. So I'm going to have a 3 plus 3. All right, so there we go. So again, just simplifying here. I have a -1 times a -1 times a 2, and then times a 6. Whoa. All right, so let's see here. I get -1 times -1 is just 1. And then I get 2 times 6 is 12. All right. So I know I got to go to -18, down to -18, and up to 12. All right. So let's see here. Multiples of, I don't know. I'm going to go with, they're multiples of 6. So I'm going to go down by 6s here by every two points. So I'm going to have to label my y-axis because the ones on the x-axis work because they're just ones, but I'm going to say that's -6. Then I've got 2 spaces is another. I got to equally space this out, -12. And then 2 more spaces will give me -18. All right, and the y-axis, again, up 6, up 12, up 18. All right, so now I'm back into plotting. One thing I didn't plot here. I didn't plot my y-intercept, which is when x equals 0, it's down to -12. So there's another point I can plot. All right, now I have another value again in between my x-intercepts. What did I do? F of -2 is down to -18. All right. And then my final point that I figured out was f of 3 is 12. So x equals 3, we go up to 12. And there, now we have a pretty good idea. It's a sketch again of what this thing looks like. There we go. So I found the x-intercepts. I found the degree of my polynomial. I found the leading coefficient. So that told me the end behaviors. Then I found the y-intercept and x-intercepts, and then found values in between those. All right, to get a nice little sketch of my graph there. Now, when we get to calculus, we'll do this in way more detail. All right, let's try something else here a little bit different. Find the equation of the function below. So now we're going the opposite way. Got to find the equation. All right, and we're going to do that in factored form. Now, the first thing I can do that's important is the x-intercepts. So I check out here where this thing has x-intercepts. And I got one there at -2. I got one there at -1. I got one at 4 here. And I got one here at 5. So right off the bat, my x-intercepts, as I just said, are -2, -1, 4, and 5. So right away, here's how I can write this graph so far. F of x is equal to, now again, in factored form, I'm going to go back there to my first page. We have y equals a times x minus an x-intercept times x minus an x-intercept times pretty much all x minus all the x-intercepts. So I'm going to write it like that. So I've got a, which I don't know yet. All right, now I've got x minus -2. That's weird. I'm not going to write it like that. The two minus signs are coming together. I'm going to write it as x plus 2. All right. The same thing with -1 here. I could write it as x minus -1. That's messy, right? So the two negative signs come together. So it's going to be x plus 1. Then I have my other x-intercepts of 4 and 5. So then I can just write it straight up. X minus 4 times x minus 5. Easy for me to write. All right. Now, we've got most of this function, except for we do not have this a value. Okay, so we got to find that a value. Now, here's the thing. We do have some more information. This is in function notation. So what it's telling us here in function notation is that when x equals 1, it's giving us a point on the graph, really. Y equals 7.2. So I'm going to put this information in. All right. So when I have f of 1, how am I going to write this? I'm going to write this. I'm going to take a few more steps here. All right. So let's see here. So f of 1 is equal to a. Now, again, I'm writing an extra step here. I'm substituting in a 1 in for x. So I got 1 plus 3, then a 1 plus 1. Then I have a 1 minus 4, and then 1 minus 5. All right, and the reason I'm saying I put in an extra step here is f of 1, I know it. It's 7.2, so I'm going to plug that in. Equals a, all right, times 4, times 2, times negative 3, times negative 4. All right, so I can simplify this here. I have a 7.2 still there. It's equal to a. Let's see. Now I got 4 times 2. All right, which is 8. Times negative 3, which gives me negative 24. Times negative 4 gives me positive. Whoops, hold on here. I messed it up. 4 times that gives me 96. I think I made an error on my note there. All right. So now I'm going to divide both sides by, oh, I know where I messed up here. That 3 should be a 2. Wish somebody had said something. So that does make that a 3. Now I got to do these calculations all over again here. Hopefully I can get back in this box. Yeah, I can. All right. See how that, you got to watch what you're doing here. All right. So 3 times 2 is 6. Times a negative 3 is negative 18. And let's see, and then times a negative 4 gives me positive 72. All right. So I didn't mess up there. All right. All right. Now, again, I want to get a by itself. All right. So I'm going to divide both sides by 72 here to get it away from that a. And my a value, I get 7.2 divided by 72. And my a value is 0.1. All right. So now I've got the equation. Well, I haven't written it down yet, but I got enough information for it. My f of x is equal to, I know a is 0.1. Then I'm going to have a x plus 2. I'm writing this equation in factored form. X plus 1 times an x minus 4 times a x minus 5. And there we go. And so the leading coefficient, let's see here. I got a 1 in front of the x, a 1 in front of the x, 1 in front of the x, 1 in front of the x. We have a positive leading coefficient. The degree of our polynomial, again, is the number of x's. So we got 1, 2, 3, 4 x's. So it's an even, right? So I have a positive coefficient, even degree of polynomial. So I, again, think back to my x squared function and look at the end behaviors. As x approaches infinity, this thing shoots up into infinity, just like x squared. And as x approaches negative infinity, just like my x squared function, this thing approaches also infinity. Just to, again, tie it in with our first note today. All right, so I'm just going to check the chat here for questions. Seems like we're all right. Okay, let's check it out now. The next one. Write the equation of the function with x-intercepts 2, 4, negative 1, negative 3, and goes through the point 0, negative 60. All right, so write the equation first. Okay, well, first off, it's just kind of like, and then we're going to sketch this thing. All right, so here we go. First off, we got the x-intercepts. So f of x, just like I did just to the last question there, I got that a value. I don't know it yet. All right, no clue. That's going to help me. X-intercept of 2, so I'm going to have an x minus 2. The next one's 4, so I'm going to have an x minus 4. Now, I've got a negative 1 and a negative 3. Now, just like I showed you before, there's supposed to be a negative sign But since there's the negative 1's negative, the two negative signs come together and it's plus. All right, and then a negative 3, same idea. It's going to be x plus 3. All right, now it goes through this point. So that's telling me there's my x value. There's my y value. All right, so I'm going to plug that in. So that means negative 60 is my total here. The a is what we're trying to find out because we're going to write this equation. And that negative 60 happens when x equals 0. So I'm going to sub in a 0 for x. So I'm going to have an x minus 2. I'm going to have a 0. Sorry, not an x minus 2. It's going to be 0 minus 2 now. Then I'm going to have a 0 minus 4. Then a 0 plus 1. And then 0 plus 3. All right, so simplifying things. So let's see here. I got a. All right, I'm going to have a negative 2 there. 0 minus 4, well, that's a negative 4. 0 plus 1, well, that's just a 1. And I get 0 plus 3, which is just a 3. All right, again, just simplifying because I want to solve for a, which allows me to actually get my a value. Let's see here. So I got a there. Negative 2 times negative 4 is positive 8. Times 1 is still a positive 8. Times 3 is 24. All right, so again, I'm getting a by itself. So I'm going to divide both sides by 24. Let's see here. There we go. And those divide each other out. And so a is going to be whatever negative 60 divided by 24 is. So I know it's negative. And let's see here. I end up with negative 2.5. All right. So now that I know the a value, I can write the function, write the equation. That's what it's asking me to do. I'm going to write it in factored form. Whoops, not y equals because we're using function notation here. I got f of x equals. We know our a value is negative 2.5. All right. Then we have a x minus 2 times x minus 4 times x plus 1. Again, it looks like the opposite when you're doing your x-intercepts, and then an x plus 3. All right. Now, that's the equation right there. But then we get to B. And B says write the or sketch the function. So we just did that in example number 1. So this question here is like a combination here. All right, so the first thing I can do, again, I can plot the x-intercepts. So I got one at 2. All right, I got one at 4. Plot that in there. I got one at negative 1. And I got one at negative 3. Okay. Now, the leading this is a degree 4. So let's get that down. Right, I got 1, 2, 3, 4 x's. So it's even degree. That's key for n behaviors. The leading coefficient, again, I got to look at my number in front of the x. I got a 1 there times a 1 times another 1 times another 1. Leading coefficient is negative. All right, so again, in terms of what's going to happen with this graph, again, the degree is even, so I think back to my x squared, but the leading coefficient's negative. So that's what the negative 1x squared looks like, down like that. So I know my function, the n behaviors, as x approaches negative infinity, y is going to be negative infinity. Here, I'm going to move that. Let's do, whoops. All right. Ah, there we go. Gave me some room here to write that. All right, so then y approaches negative infinity. And the same thing when x approaches infinity. Y approaches negative infinity. So a sketch, these are my two end x-intercepts here. One down. And going far right, it's down 2. I don't like that's a bad sketch. Come on, do better than that. Whoops. There we go. All right, now the next thing is to look at what we got in between our function, our endpoints. So we got 1, 2, 3, 4 endpoints. We're going to have to find 3 different values. So I'm going to start off with right here, x equals -2. All right, so I'm going to find the value of f of -2. All right, by plugging into my equation, which I now know is -2.5. My x is -2, so I'm going to have a -2 minus 2. All right, then I have a -2 minus 4. All right, then I got a -2 plus 1. And then a -2 plus 3. All right, so simplifying that, let's see here. Equals, I'm going to have -2.5 times -4, just simplifying it here, times the -6. Getting some big numbers here. Times the -1. It's small. And then times the +1. All right, so then I multiply those. Let's see here. -2, -2.5. Just getting the calculator out here. Oops. Let's see here. -2.5 times -4 is +10 times -6 is -60. And then those 2 ones aren't going to matter. So I get a -60 here. All right, that's big. So there's one value in the middle. The next one in the middle, I got to either do 0 or 1. Well, 0 is always easy. So I'm going to find f of 0 when x is 0. So that's in between our next 2 intercepts here. And so I'm going to have -2.5 again. I'm not going to substitute in this time because it's 0. So x minus 2, I put a 0 in there. I'm going to get a -2. X minus 4, I put a 0 in there. I'm going to get a -4. X plus 1, I put a 0 in there. I'm just getting a 1, right? And then the next one's going to be a 3. All right, so I multiply those numbers. Let's see here, -2.5. Whoops, put the half in there. Times -2 times 1. Oh, whoops, sorry, times -4. Can't skip that. Times 1 times 3. I get -60. Okay, same as the other one. All right, and then lastly, I got to find a value in between our last 2 x-intercepts. And let's see, well, obviously, there's only good one. You can use decimals, but I don't suggest it. So I'm going to use 3. All right, so let's see here, f of 3. And I'm going to shorten this up a little bit. So I got that -2.5. All right, so let's see. The first bracket, I put a 3 in there. Well, 3 minus 2 is 1. 3 minus 4 is -1 for the next bracket. Then I got 3 plus 1, so that's going to be a 4. And then 3 plus 3, ooh, 6. All right, so let's see. I do some multiplying there. And let's see here. I end up with, 60. Okay. All right, now I figured those out before I did my graph because I need to know my scale on my y-axis. All right, so I don't know. Let's go with tens. How about every block is 10. So that's going to be a -20, -40, and -60. And that's as far as we need to go because that's what our values are. And then same thing, you got to keep it consistent when you're graphing. Can't skip. You got to make everything worth the same. All right, on each axis. So on our x-axis, they're all worth 1. On our y-axis, each block is worth 10. But each 2 of them is worth 20. So we got a 40 and a 60. All right, now I'm just going to plot my points here. So let's see here. I got f of -2 is -60. So that's down here. Okay. F of 0 is also -60. All right, and let's see here. The last one, f of 3 is +60. All right, so we can do a little sketch here. So this graph goes, what did I miss here? Ooh, I think I missed something here. -2.5, because this looks a little weird. I don't know how it's going to turn here. -2.5 times 4. I'm going to redo this f of -2. I have a feeling I messed this one up, folks. I'm going to check it out, though, just to make sure. And you got to do these right the first time, says the teacher. Wow, so I'm having trouble here. -2.5 times 4 is positive, times a negative is negative, times a -1. This is going to be positive 60. Mess that up. So I'm going to erase my point here. It's actually positive 60. Up there. There we go. Let's see. I'm going to make sure my f of 3 is right. Negative times a positive is negative. Times a negative is positive. Yeah, it's going to be positive 60. Negative times a negative is positive. Times a negative is negative. Okay, I got that one right. All right, so my sketch, there we go. That kind of looks something like we would have. Now, when my kids see this big M, they think it's McDonald's. But there's the sketch of our function. Now, again, in calculus, we'll look at, is this really a high point? These two, are they really high points? And down here, is this really as low as it goes? But again, it's just a sketch. Now, the other thing, tying in with our last note, it's a degree 4. The number of turning points is n-1. So the maximum number of turning points is 3. And guess what? There's a turning point, there's a turning point, and there is another turning point. All right, so that is how we sketch and find the functions of polynomial functions, or find the graph of a polynomial function, or find the equation of a polynomial function in factored form. All right, and that's what we're going to be working with, is factored form for a little while anyways. We're going to be able to